Hey there. So in today's video, I thought we could take a look at assignment 45 in class, the derivative. Okay, so question 1 says, without using your calculator, sketch both y and y prime for y equals 4x minus x squared. Okay, so 4x minus x squared is the same as x, 4 minus x, so I've got zeros at 4 and 0, and this is a down-pointing parabola. I know this place occurs halfway in between these at 2, and if I plug a 2 in here, I have 8 minus 4, or 4. So there's the graph of y. Now, I'm also supposed to sketch y prime. Well, so here's my zero slope. And I see positive slopes here, very positive, less positive, almost 0, 0. So I've got that. And then a little negative, more negative, very negative, ooh, so very negative, like that. So that would be y prime. Using both limit definitions of the derivative to find dy dx for y equals 4x minus x squared at x equals 1. Okay, and by both what limit definitions of the derivative, I'm talking about limit definition of the derivative at a point. So the limit as x approaches 1 of f of x minus f of 1 over x minus 1. And that's going to be the limit as x approaches 1 of 4x minus x squared minus f of 1, which is 3, all over x minus 1. Okay, so I need to say then that f prime of 1 is going to be negative x squared minus 4x plus 3 over x minus 1, and that's going to be the limit as x approaches 1 of x minus 1, x minus 3 over x minus 1, and cancel, and I get that f prime of 1 is 1 minus 3, or negative 2. Okay, so that was the first limit definition of the derivative. Now what about this one? The limit as h heads to 0 of f of 1 plus h minus f of 1 over h. And so that's going to be the limit as h heads to 0 of 4, 1 plus h minus 1 plus h squared minus, what's f of 1? I believe f of 1 is still 3 over h. So we're going to have the limit as h heads to 0 of 4 plus 4h minus 1 minus 2h minus h squared minus 3 all over h. So I notice that 4 minus 1 minus 3 cancel out, and so now I'm just going to have 2h minus h squared. So that's the limit as h heads to 0 of 2 minus h over h, and now when I plug in a 0, I get 2. So f prime of, whoa, I had negative 2 here. Oh, I forgot that negative. So it is positive 2. Great, so f prime of 1 is positive 2. See, sometimes checking your work can be helpful. Okay, so that's question 2. What about question 3? Question 3, find the equation of the tangent line at x equals 1. X equals 1. So 1, 3 is our ordered pair. And f prime of 1, well, we just did that twice and came up with 2. So then my tangent line equation is going to be y minus 3 equals 2, x minus 1. 4, write the equation of the normal. Well, the only difference between the tangent and the normal is that I'm going to use the opposite reciprocal slope. The ordered pair stays the same. Okay, 5. Use your calculator to help you graph Oh, okay. So let's take a look at graphing. It's so hard to see. Oh, that's much better. Okay, so y equals, we're going to type in 4x minus x squared into y1, and 2x plus 1 here. And then finally, negative 1/2 x plus a half plus 3 plus 3.5. Okay, and let's zoom standard. So there's my down-pointing parabola. There's the tangent line at -1. And that's supposed to be perpendicular, but it doesn't really look it, does it? So let's try this. Go to zoom and choose square. That's better. Now I see perpendicular lines. So this length is greater than this length, and when you choose zoom square, the calculator adjusts the scale on this one to make it be the same as this one. And it's only in zoom square when we'll see circles looking like circles rather than ellipses, or when perpendicular lines will actually look perpendicular. Okay, use ender to confirm the slope at x equals 1. Okay, and it says use the computational screen. So I'm going to do ender, which I know is different on your calculator if you have a new calculator. We still type in the same information, comma x, comma, and we want to know the slope at 1. Okay, and I get 2. Excellent. 7. Find the average rate of change in y from 1 to 5. Okay, so y equals 4x minus x squared on 1 to 5. Okay, so that's going to be y of 5 minus y of 1 over 5 minus 1, because I'm asking for average velocity. Average rate of change. So that's going to be f of 5, which is 20 minus 25, or negative 5. And f of 1 is 3 over 4. So I get negative 8 over 4, or negative 2. So the slope, on average, from 1 to 5 is going to be 2. Does this surprise me? Well, let's take a look at that graph. Here's 1, here's 5, and the average, the slope, the average rate of change between those points is definitely a negative number. Okay, that's 7. 8. Use ender to find the instantaneous rate of change at negative 0.456. Okay, so let's go back to this, and instead of at 1, we've got negative 0.456. And it looks like 4.912. 4.912 will be our answer for number 8, when we found f prime of negative 0.456. Okay, what's 9 say? Ooh, 9 gives us a new function. So here's the sketch graph of v of t. Okay, v of t is this piecewise function. For the first 2 years, we have 2. And then from 2 to 6, we have this line segment whose slope is 150. And this goes out to 6, and this goes to 2. Okay, and that pen needs to be replaced. What's next? Sketch v prime. Okay, so that was v of t. Oh, that was v of t in blue. And now in green, we're going to have v prime. So the derivative of this first piece is 0. And the derivative of the next piece, oops, close circle, open circle. That's v prime. Okay, so I graphed that, and then I'm supposed to graph graph with n-deriv on 0 to 6. Alright, well, let's see if we can do that. That means we have to type in this piecewise function into y equals. So let's do that. We've got 2 divided by 0 test is less than or equal to x, which is less than or equal to 2. And then the next piece is 150x minus 298 divided by parentheses, not 0, but 2, test less than, not less than or equal to, buddy, just less than x. Oh, I forgot. We need to do and x is less than or equal to 6. Okay, but now that means we have to go back up to this one and put in that AND statement. It's under logic. And x is less than or equal to 2. Close parentheses. Alright, well, I like to think that this will graph. Why do I only see that? And the reason I only see that is because that slope is so steep. So let's change our viewing window. 0 to 6. Oops. 0 to 6. And 0 to 300. And steps of 3. There you go. So we have the horizontal line up to 2, and then from 2 to 6, we have this linear equation. But what are we supposed to be graphing? We're supposed to be graphing n-deriv. Okay, so I don't want this on. I don't want this on, but I do want to turn on this math n-deriv y 2 comma x comma x, and over here math n-deriv y sub 3 here, there, function y sub 3 comma x, those parentheses. Okay, so now I'm only graphing the derivatives, and if I'm graphing the derivatives, I need to see 0 and 150. So how about negative 100? Whoa, I did something I shouldn't have done. Delete, go to window, x values are all set, negative 100 to 200, and steps of it. Okay. I don't see anything. Why don't I see anything? Oh, because it's still working. Ah, there's my, that's this piece up here. This is this. And what about the piece here at 2? Well, I just can't see it, but I know it's there. Let's go to and turn the axes off. Axes off. See? From 0 to 2, we're 0. And then from 2 to 6, we are 150. Okay, so I can graph that on my calculator. That's 9c. Write the equation that gives the rate of change as a function of age. Well, that's no problem. That'll be f prime of x equals 2 for x between 0 and 2, and 150 for x greater than 2 but less than or equal to 6. All right, E. What is the rate of change at 1 year, 2 years? So we want f prime of 1, f prime of 2, and f prime of 5. Well, f prime is a constant, 2. At time equal to 2, we're included here, not here. So I get 2, and f prime of 5 is on this interval here, so I get 150. And are we supposed to include units? Nope, just the rate of change. But this would be words per year. When you're very tiny, you learn very few words per year. But then you reach that mystical place where suddenly you're able to process language a lot more. All right, there's 9. 10. When fired, an anti-aircraft shell, reaches its maximum height as given by S of t equals 1280 t minus 16 t squared. Time is in seconds, and height is in feet. Okay, so these are feet, and these are seconds. All right, at what time does the shell explode? Does the shell go straight up to its maximum height and explodes? So you could I could do minus b over 2a here, but I'm going to be all calculus-y about this, because, it's AP calculus exam, not AP pre-cal exam. And that's going to give me 1280 minus 32t. And when I think about this down-pointing parabola, the place where the shell explodes is the maximum. We have a 0 slope there. So I want to set this derivative equal to 0. So that's going to be 1280 equals 32t. You could leave your answer like that. My mother would not be happy with that answer. And I get t equals 40 seconds. 40 seconds to reach its maximum height and explode. How high will the plane have to fly to avoid being hit by the shell? All right, so we know at time equal to 40 is when it explodes, but we don't know what the height is there. So I need to know S of 40, which is 1280 times 40 minus 16 times 40 squared. Okay, 1280 times 40 minus 16 times 40 squared. And I get 25,600 feet high, right? It's called anti-aircraft shell, so it has to go up as high as where the aircraft are. All right, that's my answer to part B. There's part A. What about C? After firing, how long does the gun crew have to get under the cover so they're not hit by any fragments falling to the earth? Well, we know this is a down-pointing parabola, and this is the moment in time when the fragments hit the earth. So in that case, I'm not looking for V equal to 0, I'm looking for S equal to 0. So, part C, position should equal 0. So that means that 16t squared minus 1280t equals 0. I just moved everything over, and I'm not really sure why. I'm going to factor out a 16t, and I'm going to have t minus 1280 divided by 16 gives me 80. Oh, I knew that, because this was 0, and this was 40, and halfway between these x-intercepts is this, so 0 to 40 must be another 40 to get up to 80. Okay, so equals 0, and so at t equals 80. This produces t equals 0, and that's not falling back to the ground. This second time is when we're falling back to the ground at time equal to 80 seconds, so the gun crew has 80 seconds to get out of the way. Okay, how fast are these fragments going when they hit the ground? Well, how fast are we going is a velocity question, and so we want to know the velocity at that point. Well, let's bust out our velocity equation. Here's velocity, and I want to know velocity at time equal to 40. 1280 minus 32 times 40. Okay, 1280 minus 32 times 40. And I get 0. What? Oh, no, that's up here. Duh. We want it 80. That's what we want. Sorry. Alright, 1280 minus 32 times 80. And I get equals negative 1280. And these are feet per second. That is going very fast at time equals 80 seconds. Okay. Do we have anything else? Nope, that's it. That's the worksheet done. I hope this was helpful, and I'll see you in the next worksheet.